Okay, my outstanding friends, stay tuned. This is gonna knock you out. This is a fish that is being invaded by venom. And how does its immune system respond? Well, let's see. Okay, my friends, this is the circulatory system. This is an artery feeding down with the blood vessels, ending up at the capillaries at the vein. Now, what I am going to show to you is unknown to medical science. I'm not kidding you. When you see this, you're going to freak out. Okay, hold on to your hats. Shocker du jour. This is a fish, and this is its fin. This right here is where the vital flesh starts, right on this line here. This is venom, all right, reptile venom, invading this fish's vital flesh. And it's hitting here and ate right through the scales. And we can see the blood vessels, the veins, the arteries, everything underneath. It's just like removing the scales. And then what do you see? What you see when we can see it. Now, where did this toxin go? It tried to invade here. There's some bloody spot here. This is the major area where it invaded. It pretty much rolled off the edge of the fin and ended up invading here and causing extreme damage, which I will show you now. Okay, let's look at this closely. This is the red blood coming down. It still has some viable ingredients in it. Now, it's coming down and it's being absorbed at the end. The capillaries flush what's left into the veins. This is a vein. Now, look at this carefully. This is what's flowing back to the heart in the vein. All these little lines are the lymph ducts. This is the fluid-filled highway right here. Those fluids, as you can see, are going into the vein. The vein absorbs them, absorbs everything else except these fluids. These fluids stay and do not get absorbed into the vein. But the red blood comes down with its good quality ingredients, and then at the very end, it pinches it off at these capillaries. All right, and then it just squirts the used stuff into the veins. And that heads back up to the heart. But all these big ones are arteries, and these are the blood vessels and the little capillaries coming down. So this is what happens when you remove all the scales from the fish. All these scales are missing now. All right, before they had scales on top of them. Once the toxin came in here, it literally dissolved the scales. See up here, that's the fin. And it came down until it hit the vital flesh right here. You see where the red blood starts squirting out? This is the vital flesh after it ate through the fin. And now it's eating through the scales. And then you have down here, it's still eating through it, but it's not, you can see that it hasn't dissolved it. So there is a dissolve situation going on where it dissolves the the scales, and it's now down into the vital flesh, attacking the vital flesh. Now, I said that the immune fluids, which flow through this fluid-filled highway, it's called lymph. I say it's intelligent, and I'll show you why I think it's intelligent. Now, don't forget, we attacked this vital flesh with these toxins. And they ate through, as I showed you, and we got right down to the blood vessel layer. Now, let's see how the lymph reacts to the actual invasion site. This is sort of a dissolving site. Well, this is an actual serious invasion site. Let's take a look at that. All right, let's see if we can make heads or tails of this. Right here is the vital flesh. This is just the fin, means very little, and we're invading it with all these toxins. Now we hit the vital flush right here. And how does the vital flush react? Well, it sends out all its lymph fluids. Those are all the lymph fluids that are trying to sweep away all these toxins. And they're bringing it all down into the lymph nodes to be worked on. And these are all lymph nodes down in here. Now, this is a real serious trying to stop it from coming in. It just doesn't work. So this stuff has worked its way over here, all the way over here, and now it's breaking through into the vital flush right in this area here. Now don't forget, this is all lymph fluid, and it's all boiled together. It's not those little tiny tubes which I showed you before. And this is where we're really going to see it trying to pull all this green toxin away. You see how it's turned into just a river? This has reconfigured its little tubes to come together to drive that fluid up into this area. They've all come together to drive it up in here. Before I showed you they're all going this way and that way, they're just everywhere. Well, now they have intelligence. They say, you got to get this stuff out of here. It's going to kill us. So they send all the lymph fluids right up close and personal, straight away. You see them? They're heading all the way down this way, grabbing up all this nasty stuff. This is a toxin from the reptile venom. And it's dragging it down here and trying to bring it over to the lymph nodes. You see this whole river? There's a river coming down there, a river coming over here. They're heading, each one of them is heading into another lymph node. See it? A lymph node, lymph node, lymph node, lymph node, all the way down. So what do we see? We see the lymph fluids coming in from this invasive area, sweeping away the green stuff and bringing it over down in a whole series of cascades to the lymph nodes. Now, a lymph node is supposed to take toxins, which this is a serious toxin, and it's supposed to disassemble them and break them up and destroy them and clean it up and send the lymph fluids back in a nice pink fluidy way. Now, if it can't handle that, the lymph node will die. It's called lymphoma. It's a cancer, basically. It's an invasion of this tissue, and it kills it. What killed it? This toxin. Because it was literally venom. All right, so this is serious stuff. Normally, you're not going to be dealing with that in your body. Your lymph nodes will clean up things that come to it if the chemistry in here is right. And the chemistry in your body is correct to clean up most of the stuff, and the rest of it gets dumped into the lymph nodes. If your chemistry isn't right in here or the lymph nodes, you're going to have a problem, and you could possibly get lymphoma. But in this case, it's like spontaneous lymphoma. It just came down here, tried to clean it up, could not clean it up, and it destroyed all these lymph nodes. All right, so let's take it from the top. It sweeps the lymph in its now river form up against the invader. It takes that chemistry down to the lymph nodes to try to clean it up. So what we see is all these lymph nodes coming down, coming down. Now let's just take the first one here. That is what's called a lymph node. And what it does is the chemistry comes in here, cleans it all up, and sends it back out here in nice, clean, pink form. Well, in this case, it can't do that because it's dead. The first thing is, as this lymph enters this lymph node, there is these webbing here. All right, that webbing is a filter. And it tries to keep the really heavy-duty stuff out, so it sort of comes through, you know, like a filter, filters out the big stuff and lets the little stuff in, cleans it up, and eventually that'll all work its way in. However, in this case, it's just too much, and it has killed this lymph node. It's totally dead. You see it's coming in from the side? That's not supposed to be dead like that. And it's supposed to come out this side nice and clean. Well, it's not coming out this side at all because it's dead. It comes in from this side, and it is, at the other end, it's just dead. It cannot clean it up. And this is not the only one. They're all the way down the line. There's the next one, dead again. And another one here, dead again. You can't stop it once it's just too overwhelming. Too overwhelming. They all have the same structure. You see, all feeding into the lymph node and all this webbing, this filtration device. Can't handle the influx. Way too much toxins. So that I've just shown you. The lymph node in its natural state, before, just as the scales are being dissolved, you can see the lymph node. Let's go back and look at it again in a second. But then we know that they're just all sort of meandering around, but when they're called on, they can turn into a river, which we have just seen, that river attacking these lymph nodes. There's a river. That didn't just happen by accident. They weren't anything like that before. They were nowhere near like that. They're just sort of meandering around looking for something to do. Well, they found something to do. Try to get rid of that green stuff, which is the toxin. This is venom. And it could not handle it. Just couldn't handle it. Okay, there's just absolutely no question that the veins are absorbing from the blood vessels and the capillaries. They're absorbing it right into the veins. The veins they're not porous, but they absorb. So I guess you'd have to say they're porous. I looked it up, and they don't understand it in medicine. They just don't understand it. These are the black ones that are sucking that stuff back up, because everywhere in your body, the veins have to absorb. It's just not one very end piece there and they suck it all up from there. No, it's everywhere that you're using up this stuff, where your skin is and your tissue is. It's using it up. It has to get the junk out of there, and it does through the capillaries. The blood comes in, flushes the tissue, it goes out through the capillaries. These are where it's being absorbed. Your veins are not solid tubes. They're just not. The arteries and so forth are pretty much solid. They turn into the capillaries, but as they come down, they're pretty well solid. They're not leaking anywhere until they hit their capillaries and so forth to distribute the blood everywhere. So this is an issue that they don't understand. Plus, they don't understand the little fascia latch that's on every single organ. That's another thing that I just discovered. That I've been working with some people about this, and so far they haven't accepted it, but as far as I'm concerned, there's no question about it. I'll show you. Okay, as far as I'm concerned, every single investment in the body, like this piece of meat, has that little flap on it right there. That's this flap. This little triangle, and it goes into the next body part, and it transfers the fluids that are surrounding this chicken breast through these two tubes. I'll show you very clearly in a second. This is the latch that snaps this thing into the organ. So right there is this. It snaps it right in like that, and then this thing right here hangs off the edge, and there's two little tubes, and you can see them very, very clearly in this with a microscope. You can see where they leave to go into the next organ, and this is all the fascia. It collects right at the end, just like here. There's a little gnarly spot. That's, you don't eat into that, and I'm going to show you one that was cooked more than this. Now, this is where we have the fluids coming out, and they're coming out of these two tubes. And I think there may be an organ right there that nobody's ever known about, because all of the fluids surround every organ in your body, and then they leave through here. Now, are those fluids the same going into the next place? I don't think they are. I think they change it, and I think that's the thing that right there might change the chemistry of the next one. And here it is cooked down to where you can see it very clearly. You see this? This is that That's this right here. That's this right here. All right? It's coming down, and there's two tubes in it. There's one tube comes down, and there's the other tube. Now, this little white thing inside of it, I don't know what that is. I didn't put it in there. It comes down with it. Now, then it goes into this glob. What that glob is, I don't know. Is it just bloody connective tissue? Of that, I don't know. I think it might be an organ. It's got some chemistry look to it. It's got a different look to it than just a piece of meat. Now, don't forget, this is coming off these two tubes. Now, this is here it is right here, what I have in my shop here. This is the one that is this yellowy stuff here. That's this stuff. Now, this was cooked till this stuff turned brown, and it was tasty. Now, this one didn't get cooked. That's just raw chicken. But it has the same thing. This is cooked down to where we can see the tubes, and we can see this ball of stuff, which is this ball of stuff right here. This is exactly what's going on. The two tubes come down, and you got this ball of stuff. What it is, I don't know. Is it just the fat of the gluey little fascia that it hooks? I don't know. This we must investigate, because if this is an organ and it changes the chemistry, that could be what causes cancer. If this organ fails, and every single one of them has a little tip like the exact same thing, and if that is an organ and it failed, maybe that's why people get cancer. I don't know. And then this up here is the latch, where it really latches in. And that's right up here. That's the latch, and then there's the tag that comes down. The two little dots on the end here are where it transfers the fluids into the next one. And it's on all of them. I have a ton of different lungs here. Every one of them has it. It's very obvious on the lung. Well, this is a piece of meat. Extremely obvious on this one because of the preservation of this particular chunk of meat and the fascia. Okay, I say this is not correct. I said, are veins porous? It says, no, they're a continuous closed loop. But then they talk about the capillaries. So let's go through this. The structure helps blood flow efficiently through the body and prevents substances from leaking out. Let me tell you something. That is being sucked into that tube. It won't leak backwards because the blood suction, it's not blood pressure. It's blood suction. Otherwise, it would leak back. It's being pulled into the veins. This is something they don't understand. I don't disagree 100%, but I disagree a lot about this. Capillaries, I agree. Capillaries are smallest blood vessels. They come down from the arteries to the blood vessels to the capillaries. Most of the exchange of gases and nutrients and waste products between the blood and tissue occurs in the capillaries, which I don't agree with that totally, but not necessarily totally disagree either. There is a lot of exchange there. Now, the capillary walls are thin and semi-permeable. Yeah, they go in and out, allowing substances like oxygen, carbon dioxide, glucose, and waste products to pass through at the capillaries, which I show you end up at the veins. All right, veins, by contrast, are large. They carry blood back to the heart, generally impermeable. Well, then they say to most substances except a few things like certain small molecules, or in the case of damage, they leak. Now, key points, It says no porosity. The walls of veins are not porous enough to allow for large-scale exchange like capillaries. Well, the capillaries go right into the veins. This is not correct. As I showed you, this is the arteries. These are the blood vessels. They end up coming down into smaller and smaller tubes, and then down into the capillaries, which end up going right into the veins. Right in. Well, they don't leak backwards because they're being sucked. Otherwise, they would leak backwards. I agree. Now, is the blood pressure pushing it in? that's possible, but I think more likely it's a combination of push and pull. Push and pull, push and pull, push and pull. They don't leak backwards. And I talked to some autopsy people, some really top-end people, and they don't realize this. They don't understand that these things are porous like this. There's no other possibility. How can you deny seeing that? That's the capillaries ending at the veins. You have capillaries and veins and arteries throughout your entire body, everywhere. They don't always take the blood, the vein blood, and go to some special place and drain it all back. No, it leaks into the veins from everywhere it's being used. Very, very, very obvious. Now, I'm going to end up with where we started. This is an invasion, and I now understand very well the fascia with this fluid-filled membrane that protects everything in your body. And hold on one second. Let me close all these things up. I got a million going on. Now, again, we're here. What is,